Alright, time for another draftphysics.com video presentation. We're going to do the experiment some more. So a second round of kinetic energy experiments, and I think this is where they are. So it's pretty good in terms of being able to see it. So I made a new pendulum. It's more like a ballistic pendulum, what they use to collect the energy from bullets, except those are usually filled with clay, and this is a steel. So it's heavier, which means that there's less margin for error in terms of the momentum, and because you have more units to deal with. So, and it's also slower speeds because of the extra weight, and so that's an advantage. So haven't really previewed this at all. I'm just going to go through a few examples, and I'll edit out the part you don't need to see and just do the collision parts, and we'll do a few of the collisions. And the first one I looked at looks pretty much like half the speed to me. So anyway, you can sort of go by the distance. You know, half the speed would be 1/4 the distance rising back up in gravity. So if you took the total length, so you can see the total distance it moves and the total length it moves away. And if you, that total length of the distance it moves away, if it moves away at 1/4 the total distance of the moving object, then you know that would be proportional in gravity to double the speed. So if it's less than 1/4, it's less than half the speed. If it's 1/4, it's half the speed. And if it's more than 1/4, then it's faster than half. Alright, that should be enough of a statement. And now we'll just do the frame by frame thing and see how this goes. So I'll see if I can catch these at the right moment. Oh, that was the wrong moment. Yeah, so, but you saw the distance anyway, so we can do the frame by frame release. And yeah, it's pretty small. It's only about an inch, and a little over an inch, and it moved like 4 inches, right? So something like that. Alright, so let's just do that one over, just because we probably can, and it's not going to take that much time. Alright, just catch it. See, it's, yeah, I gotta catch it before I release it, which is the tricky part. So I'll go a little further and say yes. Alright, there we go. Now we got it. So I'll just go frame by frame and count the frames. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 to hitting. And then leaving is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You can see, not doing too fast. 12, 13, 14, 15, 16, 17, 18. Pretty much done. Alright. So I will pause and move on to the next one. Alright, this should be about right. So it's a little bit more distance, so it should be a little more velocity. Oops. Yeah, hopefully. Hopefully. Come on, let go of it. Come on, let go of it. What are you waiting for? I'm sure he's going to let go of it. I'm sure. Any minute now. Damn it. There it goes. Okay, a little bit too late, but we can get an inch worth. So, it's like at 9.5, 1, 2, 3, 4. So that was only 4 for almost an inch, I'd say. So it's like 1/4 of an inch. And then we got 1, 2, 3, 4, 5, 6, 7, 8, 9 to go another inch. So 4 to 9, clearly less than half the speed. And in none of these cases does the lighter piece reverse. Not that I've noticed. It's always still going forward. So that's sort of consistent with what Descartes would have predicted. Alright, so we'll go to the next one. Alright, this one, another kind of a pretty good distance. 1, 2, 3 plus inches going in. So, 1, oh, whoops. Yeah, my bad there. That wasn't supposed to happen. Alright, supposed to do this. Alright, come on. Single frames. Come on, come on, come on, come on. See, it wouldn't matter me clicking this thing, it's just that every now and then it hangs and it won't do me with single frames. Alright, what do I want to do here? I want this not to happen. Okay, my mistake again. Yeah. Well, shit happens, as they say. Alright, I'll try one more time to get this right. Okay, got it. Alright, so, counting now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15. And leaving, let's see what it is per, I mean that was for like 4 inches. So I didn't really look, 3 something inches. And then leaving 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 for 1 inch. Clearly a lot more. Clearly. And it goes probably 1.5 inches. And so it's half the distance. Total distance is still around half, so clearly not 3/4. Clearly half. So let's find another one. It should be back. And so counting. So this one looks like it's let's see, 8.5, 9.5, 10.5, 11.5. It's, you know, a good 3 inches. So a solid 3 inches. 1. Oh, I did it again. All right. Out of practice or something. I really don't have an excuse. Damn it. Just missed, really. Well, I didn't just miss. I did miss. Okay, there it is. Got it. Alright, so it's about, now it's 3.5 inches, right? Let's see. 1/2 inch. 9, 1, 2, 3.5-ish. Almost 3.5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16. And leaving 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, blah, blah, blah. Much shorter distance. Alright. So, you know, 4 inches to less than 2 inches, right? 1, 2, about 2. So 4 to 2. It's pretty close to half. Alright, going to the next one. Alright, should be back. I'm going to try this one. Hit the right button. Alright, looks like 3 and plus again. 3 1/3, something like that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 for 3 1/4 inches, 3 1/3 inches. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 for 1 inch, and it's almost 2 right there. I think that's 2 inches. Okay. So, anyway. Alright, next. Here, it should be close. I don't quite let go yet, or else it's not working. No, it's working. Alright, so it's starting to move now. I should be saying how many it is, right? So let me get, when I get to the 10, I will attempt to mark that. Alright, so that almost looks like it's almost 10. Yeah. So 1, 2, 3, 4, about 4 to get to the 9. So 4 units per inch, 4 frames per inch. And we'll get to the bang. Alright, so there's hitting. And well, we'll wait till it gets to the 8. And one more. Okay, that's the 8. So 1, 2, 3, 4, 5, 6, 7, 8. That's all I can see. So 4 and 8, half. And again, you can see it's very little energy is left in the smaller object. So clearly it's almost 100% transfer. I mean, it's so much of the energy has been transferred. So 4 to 8, it could be 8.2, you know. That's all you need. There's 0.2 left in the other thing, you know, that kind of thing. So really close to half. I mean, not just close. I mean, it looks just like half, you know, pretty much. I mean, I could go a little further. Yeah, see, I mean, adding that 1 little millimeter, so now you could say 4 to 9, and that wouldn't be out of bounds. I mean, I guess I should draw lines on my screen or something to make this even better. I guess I could draw like graph paper for a background. Maybe that would be the way to go if I had graph paper. So maybe I'll try to find something like graph paper and put that as the background. Yeah, see what I can find. So anyway, I'll do a couple more. Just you know, you don't have to listen to the rest of this. It's just showing you that this is still quite an open question. This 2/3 thing, yeah, hasn't quite been proven. And nothing's been proven by anybody. All right, so I'll be back. Alright, this one was already on the move, but that's okay. So we can still get to the 10, let's say. And that would be the 10. So 1, 2, 3. So this one's going a bit faster, so it's only 3 units. As far as I can tell. Yeah. And so we'll let it hit and then count. So this looks like the hit right here. Alright, so let's get to the 8, and that's about here. So 1, 2, 3, 4, 5, 6, 3, 6. Can't really do much, you know. Pretty clear. I mean, you know. That's all I can. That's what I see. I don't know what you see, but that's what I see. Right, try one more. Alright, last one. Let's see what we get here. So almost to the 10, and that's about the 10. So 1, 2, 3. That's a little. Well, that's pretty close. So it's 3 again. And there's the hit. And so let's see what we get. We got to get to the 8. Alright, so that's about right, I think. 1, 2, 3, 4, 5, 6, 7. And, well, I might go, yeah, could go one more. Okay, so that's 8. So 3 to 8. Clearly slower. Alright, so I think that's enough of a demonstration of proof of theory anyway, that you got to take all this stuff with a little bit of skepticism. You know, experiments, the details do matter. Lots of, you know, it's not just as simple as, you know, seems like, is like. Nah, you got to be a little more careful than that. So anyway, these experiments clearly demonstrating there seems to be no indication of any ability for the one mass object to put 2/3 the velocity into the 2 mass object. And so we'll see. I do have a strobe light. You know, it flashes at 1,000. You know, 1,000 hertz. At 1 hertz, or yeah, 1,000. Well, anyway, 1,000 flashes per second. And, you know, a camera, and I'm thinking maybe I can take a, you know, time-lapse photograph kind of thing. But yeah, I don't know, that seems awful fast. I mean, 1,000 flashes per second might be too many, but who knows? We'll see. Maybe I'll try that. I have another camera I could use, so I could try that too. But really, this looks pretty good. I guess the real point is to have the background, see if I can find a grid to put in the background. And, you know, I think that's would be enough to be more precise in the measurement. I suppose I could cut the video and move the tape measure up. Well, maybe I'll just move the tape measure up next time I do this, so I'll do that as a minimum. I'll just move the tape measure higher. So I can do that. And, what the hell? Oh, yeah, okay. I just have to switch this thing. So, anyway. Yeah, so that's experiment number 2. Probably will be a 3 and 4. We'll see how it goes. I'd rather it just get decided by better experiments than these, but no one's doing better experiments. Yeah, they're doing worse experiments from silly camera angles. So anyway, till the next time. No point in... It's for what it's worth. There you go. For what it's worth. It leaves me very unconvinced of the kinetic energy, free energy theory, right? I'm not going to rush out and build my perpetual motion machine just yet. Okay, leave it at that. So, till the next time, touch. This has been draftphysics.com video presentation and such.